The new Ferrari suspension for the 2025 Formula One single-seater brings several opportunities, but also several challenges. As expected, technical director Leclerc has overseen a switch from Ferrari's traditional push-rod front suspension to a pull-rod layout as favored by McLaren and Red Bull. But the rear remains pull-rod in contrast to those teams. Last year's car was invariably the fastest of all through slow corners, but lagged behind McLaren and Red Bull through high-speed corners, with a lower downforce ceiling. Ferrari have elected to attack this shortfall in quite an aggressive way. The new pull-rod front suspension allows a greater degree of anti-dive to be built into the geometry, in turn allowing the car to be run lower and enhancing the downforce created by the underbody at high speed. Looking at the images of the car and comparing them to its predecessor, it is clear that Ferrari have increased the wheelbase by extending the gap between the front wheels and cockpit. This in turn allows the side pods to begin further behind the wheels than previously, which allows the airflow to the pods and underfloor to be less disturbed by the front wheel wake. It implies that the previous arrangement played its part in exhausting the aero potential of the SF-24 through those high-speed bends. With the greater space between the wheels and cockpit, the airflow has a better chance of being directed with greater energy and precision. The greater volume ahead of the side pods has allowed the undercut to be enhanced. The radiator inlets are subtly different and the rear wing design appears to be new. Ferrari report that they have made detail changes to the operation of the power unit to give a better spread of performance through all circuit types. Focusing specifically on the front pull rod suspension, the management of the forces that the two wishbones must withstand is different from the 2024 pushrod version, with the implication of a different vehicle dynamic. The suspension kinematics used by various cars is complex, and in a direct comparison surrounding factors must be considered. The vehicle system is unique and varies for each car. For this reason, the discussion cannot be isolated to just the suspension layout. Furthermore, the actual thickness of the arms is hidden by carbon aerodynamic covers, which serve to make the arms true aerodynamic devices. So let's try to understand the work done by Ferrari on the front pull rod. With the current push rod geometry, during cornering, not only is the lower wishbone subjected to tension, but a compressive force arises in the upper wishbone, which was absent in the old push rod setup. This new compressive component leads to the generation of a moment around the roll axis, which reduces the car's rotational ability in corners. This is a secondary problem that all cars using the pull rod system encounter. On the other hand, in a pushrod suspension, only the lower wishbone is subjected to tension during cornering, while the upper wishbone is almost entirely unloaded. To overcome this problem, the Maranello team's technicians and engineers decided to position the steering arm at the bottom, in line with the lower wishbone. This decision, shared by several other cars, allows the steering arm to work under lower loads and, consequently, favors the rotation of the entire wheel assembly. The lower total load comes from a specific fact. The forces are distributed between the two wishbones, which reduces the overall load on each individual element. In this way, Ferrari has recovered part of the disadvantage related to the compressive force in the upper wishbone by using the lower load on the steering arm. However, it is possible that the difficulties in corner entry may be related to the suboptimal management of this compressive force, which causes the car to delay in reaching the apex. With other cars, there are some differences in the positioning of the steering arm. The Ferrari SF-25 single-seater adopts the same setup as the Red Bull RB21, positioning the arm parallel to the first link of the lower wishbone. McLaren, on the other hand, along with Mercedes, prefers a more rearward position, parallel to the second link of the lower wishbone. Overall, the engineers at Maranello have tried to mitigate the problem by working on the calibration of springs, dampers, and anti-roll bars to counteract this additional compressive force. It should be noted that this component acts directly on the chassis, considering that the suspension components have been moved to the lower part, making them more difficult to manage. There is therefore a difficult mechanical compromise on the SF-25 car. Another issue that could arise in the slower sectors of the track is related to the lateral load transfer induced by the suspension. Depending on the location of the arm that transmits the forces, strut or tie rod, relative to the upright, a lateral load transfer, due to the mechanics, is favored, which occurs even with a reduced lateral force. The closer the arm is positioned to the central axis of the hub, both laterally and vertically, the greater the value of this effect. In other words, depending on where the arm transmitting the forces is anchored, there will be more or less mechanical grip at low speeds, leading to a different suspension movement. Teams design different types of uprights specifically to favor this type of load transfer, which, as mentioned, is related to the mechanics. For example, on circuits like Monaco, this phenomenon is highly desired, given the almost complete absence of fast corners, where significant lateral load transfer occurs. With the suspension kinematics chosen by the Ferrari engineers, things become more complicated. With the pull rod of the SF-25, this action, in turn, means that there are greater compromises to be made. The reason is linked to the fact that the tie rod works in tension, and the magnitude of the force transmitted to the supports is smaller. This is one of the real headaches that Ferrari has not yet been able to manage, as the arm, by design, transmits a lower force. The Italian team decided to anchor the arm directly to the hub, without passing through the upper wishbone. This geometry results in lower suspension efficiency on the SF-25, particularly in the slower corners, in case the various compromises have not been properly balanced. Time is needed for the Maranello team, and this aspect was known from the beginning of the 2025 Formula One season. To address this issue, Ferrari has worked on roll stiffness, allowing for greater front-end flexibility to aid entry. However, at this point, a certain compromise must be found to allow the floor to work optimally, as it requires more stability to handle the aerodynamics effectively. An important point here is that solving the technical issues related to the pull rod will require time. It is necessary to understand how to overcome each of these mechanical issues. The suspension layout of the McLaren cars is more extreme due to technical choices and years of development that led to the conception of a system that strikes various compromises. This was the risk Ferrari faced in the last season of regulatory continuity. In the Chinese Grand Prix, Ferrari's engineers were very interested in the MCL39 suspension. The positioning of each arm has an effect on the overall system. However, there is often no direct link to a single parameter. Therefore, it takes time to try to understand how to extract the most from this type of suspension, not from the pull rod layout itself, which involves minor changes that the Italian team has already partly addressed, but rather from the positioning of each arm. The SF-25 single-seater suffers from a lack of rotation due to a rearward global balance. The management of longitudinal and lateral load transfer must be reviewed in order to unlock performance at the front. All of this, keeping in mind that the problem is connected between the front and rear of the car, so the system as a whole needs to be improved. The Ferrari engineers and technicians hope to be able to address this during the upcoming triple header in Japan, Bahrain, and Saudi Arabia, 3 races that are already crucial for the future of the prancing horse in the 2025 Formula One Championship.